In the previous few videos, we've talked about collinearity of vectors, and we've also looked at how we can write the vectors in the component form. In this video, we'll combine these two concepts and figure out how we can check whether a vector is collinear to another one just by looking at the components. So let's first recap. What do we mean by collinearity of vectors? And just to be clear, we're talking about free vectors here. So here are a bunch of vectors. We have this one, this one, this one. Let's label them A vector, B vector, and C vector. Let's add a few more. We have this one as a D vector, this one as E vector. All right. So which vectors are collinear and which vectors are not? Pause the video. Think about it. Okay. So for vectors to be collinear, they need to be in the same / opposite direction. A, B, and C are facing the same direction, which means they're collinear. And D and E are facing the opposite direction, which means they're also collinear. But what if we did not have the visual? What if we only had the direction ratios or their components? Can we figure out the collinearity by using the components of vectors? This is something that we'll figure out in this video. The questions that we'll address are, what can we say about direction ratios of collinear vectors? And what can we say about the components of collinear vectors? So let's do that with an example. Here are these two vectors, A vector and B vector. We have to show that these two vectors are collinear. We're given the component form of these two vectors. So pause the video. Think about how we can show that these two vectors are collinear. Okay. If you pay close attention, you'll see that B vector, which is -4i cap plus 6j cap minus 8k cap, that's actually equal to -2 times A vector. That's -2 times 2i cap minus 3j cap plus 4k cap. -2 times -2 is -4, -2 times -3 is 6, and -2 times 4 is -8. One vector is a scalar multiple of another vector. In this case, B vector is equal to -2 times A vector. So B vector is a scalar multiple of A vector. This means B is a scaled version of A vector. They have different magnitude, but they have same / opposite direction. B vector is actually parallel to A vector. And we know that free vectors that are parallel or opposite to each other are actually collinear. So this is how we can prove that B and A, both of these vectors, are collinear. And in general, when one vector is a scalar multiple of another vector, these two vectors are collinear. And because we're getting this vector by multiplying this vector by some constant, their direction ratios or components will be in proportion. Look at this example. We have 2 divided by -4, -3 divided by 6, and 4 divided by -8. The ratio of their components, their x component, their y component, and the z component, the ratios are same. They are in proportion. 2 by -4, -3 by 6, and 4 by -8, all of them are equal to -12. So this is a good check that we can use to figure out whether two vectors are actually collinear or not. Let's take another example. Show that this vector and this vector are collinear. Pause the video. Try this out. Okay. Let's check the ratio of their components. 4 by -2, -1 by half, and -2 by 1. So this is -2. This is also -2. And this is also -2. So all three are equal to -2. This means they're in proportion. This means these vectors are collinear. Now this is how we can test collinearity for vectors. But what about collinearity of points in 3D? So if you have 3 points, 1, 2, and 3, how do we check whether these 3 points are collinear or not? If we know the coordinates of these 3 points, can we figure out whether these points are collinear or not? Pause the video. Think about how you can figure out a strategy for this. Okay. So if these 3 are the points, we can have some vectors. So let's say we have one vector going from this point to this point, and another vector going from this point to this point. So these 3 points are collinear when these 2 vectors are also collinear. If you move from this point to this point and you're moving along the same direction to this point, then this means your 3 points are collinear. So for 3 points, we can find 2 vectors and prove collinearity of those 2 vectors. That's method 1. We can prove that green and yellow vector are collinear. But there's one more method. We can try forming a triangle, and if we fail to do so, then these 3 are in fact collinear. So if this side, this third side, is equal to the sum of the other two sides, then we don't have a triangle, which means we are having 3 collinear points. So this is something that we can do. We can find their magnitudes and check whether adding 2 of them gives us a third one. If this is the case, then these 3 are collinear. If this is not the case, then these 3 are not collinear. So let's practice. Show that the points A, B, and C are collinear. We'll try doing this using both the methods. So pause the video, give this a try. Okay, let's do this by method 1. Let's form 2 vectors. So let's form AB and BC. Let's prove that AB and BC are collinear. So AB vector will be 2 minus 1 I cap plus 6 minus 2 j cap plus 3 minus 7 k cap. And BC will be 3 minus 2 I cap plus 10 minus 6 j cap plus minus 1 minus 3 k cap. So let's simplify. AB vector is I cap plus 4 j cap minus 4 k cap. And BC, that's going to be I cap plus 4 j cap minus 4 k cap. Look what we have. We have AB vector and BC vector, and both of them are equal to I cap plus 4 j cap minus 4 k cap. We were looking for vectors that are proportional, but these vectors are in fact equal. So these two vectors are not just parallel, they're actually equal, which means A, B, and C are not just collinear. B is sitting right in the middle of A and C. So AB vector is same as BC vector, which means not only is their direction same, their magnitude is same as well. So yes, A, B, and C are in fact collinear. Let's try method 2. So in this method, we'll find magnitudes of these vectors. We already have AB and BC, so let's find AC. So AC vector is 3 minus 1 I cap plus 10 minus 2 j cap plus minus 1 minus 7 k cap. So let's simplify this. This is 2 I cap plus 8 j cap minus 8 k cap. And let's find the magnitude. So mod of AC vector, that's going to be 4 plus 64 plus 64. 2 square is 4, 8 square is 64. So 64 plus 64 is 128 plus 4 is 132. So this is square root of 132. And that's equal to 2 times square root of 33. And what are the magnitudes of the other two? So mod of AB vector, because these two are same, we'll only have to check this once. Mod of AB vector is same as mod of BC vector. That's going to be square root of 1 square plus 4 square plus 4 square. That's 1 plus 16 plus 16. That's 32 plus 133. So that's square root of 33. And yes, these two sides are equal to root 33. And this side is twice of that, 2 root 33. So AB plus BC is equal to AC, which means using the magnitudes, using their side lengths, we can say that these 3 points are in fact collinear.